Hello friends, so in this video we'll study about clamper. So clampers are of two types, positive clamper and negative clamper. As you can see that in positive clamper the wave is shifted in positive direction, and in negative clamper the input wave is shifted in negative direction. So we follow these two steps to find out the output of a clamper. Number one step is assume the input to be a square wave. uh, Whether the input is sinusoidal wave or a triangular wave or any type of wave, you assume that your wave is square wave only. And number two is start with that half cycle in which the diode is in forward bias. So now let us start with these two clampers, circuit 1 and circuit 2. So in circuit 1, you can follow we will follow our steps. So step number 1 will assume the square wave input, and step number 2 will assume the positive half cycle, because in positive half cycle the diode is in forward bias. So when the diode is in forward bias, the output is 0, V output is 0, because these two points are shorted, so potential difference between these two points are 0, and the current finds a closed loop. So what will happen? The capacitor will charge, this capacitor will charge up to 5 volt with a polarity of plus and minus, like this. Okay, and as we know that capacitor charges and discharges with a time constant tau, and tau is equal to RC. So in next half cycle, that is negative half cycle, what will happen? The diode is open circuited in reverse bias, so the capacitor will not discharge, and the capacitor will behave like a battery source. So it will behave like a battery source. So in negative half cycle, the polarity of input square wave is positive, negative. So input is also behaving like a battery, and capacitor is also behaving like a battery, and batteries are connected like this in series. So we know then when the batteries are connected in series, we add the potential. So minus 5 and minus 5. So V output is now minus 10 volt. So by combining these two positive and negative half cycle, in positive half cycle we are getting 0 output, and in negative half cycle we are getting minus 10 output. So the output waveform V output is like this. So you can see that the total waveform is shifted in negative direction. So now circuit 2, in circuit 2 the diode will be in forward bias in negative half cycle. So according to step 2, we'll start with negative half cycle. So negative half cycle means negative 5 volt. The capacitor will again charge, the output is again 0, because the potential difference between these two points is 0. So but the polarity of the capacitor is now reversed, it's now negative and positive. Previously it was positive and negative, this like this. Okay, so when the cycle changes, that means when the cycle changes from negative to positive half cycle, then the polarity of input will change, but the polarity of capacitor remains the same, because again the capacitor discharge with a time constant tau, which is equal to RC. Okay, so it won't discharge just after the negative half cycle. So again it will behave like a battery, like this, with polarity this. Now the batteries are, both the batteries are of plus 5 volt, so at the output we'll get plus 10 volt output. So again we'll combine these two half cycles. So in negative half cycle we are getting here this red, negative half cycle the output is 0, and in positive half cycle the output is plus 10 volt. So this is the combined output, V output, is equal to like this. Okay, so thank you.